Hi there. In this video, we will unravel the mystery of functions, a key concept and sometimes confusing that shows up in almost every SAT math section. Let's start with the basics first. For the functions, we simply replace y with f of x. In the functions notation, f of x equal to y, x value is the input and f of x is the output. For example, if f of minus 2 is 10, here the input is x, which is equal to minus 2, and the corresponding output is 10, which we call f of x or y. The corresponding point in the xy plane would be minus 2, 10. Here is a SAT style question evaluating functions. If f of x equals x squared minus 5x plus 6, to find f of 2, we just plug in 2 in place of x. So we get f of 2 equals 2 square minus 5 times 2 plus 6. Further solving, we get a 0. Now, let us try to identify the graphs of different types of functions. The first one, f of x equal to x, is an identity function, which we also call the line y equal to x. The graph is a straight line. The squaring function is a degree 2 function, where the graph is u, or we call a parabola. The cubing function, which is a degree 3 function, has a graph that is the shape of an. The square root function is a positive function. The input x here is positive and the output is also positive. Hence, we see the graph only in the first quadrant. The graph of a cube root function is an elongated S, similar to again the cubing function. Absolute value function has a similar behavior to that of squaring function, and the graph here is a V. Absolute value function is also a positive function where the output f of x will always be positive. Sometimes in SAT, you may come across few questions where you see a function inside a function. Here in f of g of x, the g function value is the input to the f function. For example, if we have f of x equals 3x minus 4 and g of x equal to 8x, to find f of g of 1 by 2, first we need to find the function value g of 1 by 2, and then you plug in the output of the g function as the input to the f function. Solving further, we get the required answer. For SAT, we have mainly two kinds of functions. One is linear and the other is exponential. The general form of a linear function is f of x equals ax plus b, where a is the rate of change and b would be the initial value of the function. Every linear function has a domain and range. Domain is all the input values and range is all the output values. For example, if we have f of x equal to 2x minus 3, the initial value of the function would be minus 3, which is also the y-intercept in the graph of the linear function. For the corresponding x values, we have the function values. All these points put together, we get a graph which is a straight line. The general form of an exponential function is f of x equals ab to the power x. Here again, we have the rate, which is the b value, and a would be the initial value of the function. The function would be an increasing function if the factor b is a value which is greater than 1. And the graph would be a growth. If the function value keeps decreasing by some p percentage, then the factor b would be equal to 1 minus p over 100, and we get a b value which is less than 1, and the graph would be a decay graph. For example, if we have f of x equals 100 times 1.3 to the power x, so the 0.3 represents there is a 30% change in the value of the function for every increase in x. And the b value is 1.3, which is greater than 1. So it is an exponential increase. So far, we understood that the graph of a linear function would be a straight line, and the general form would be y equal to ax plus b. The quadratic function is a degree 2 function, and the graph is a parabola. The general form of an exponential function would be ab to the power x, and the graph simply would be a